this is the summary of what is happening in the cement based fly ash based cement in India. Everybody is aware of the fly ash is no more a waste material. It has a lot of utility in the manufacturing of cement, and even if you are replacing 35 to 40% of cement, it is a great service to the society, because that much less cement is produced, that much less amount of carbon dioxide is produced, and application of fly ash in cement and concrete is beneficial. This has already been proven by several guys, and there is IS 456 also, which talks about replacement of cement by the fly ash. You might come across people who are grinding the fly ash. This becomes ultra fine fly ash, and ultra fine fly ash has very niche market all over the world. This is what is known as ultra fines in the fly ash. There is another way of finding out or filtering out the fines from the fly ash. It could be by adopting different type of classification systems. So, there are classifiers. In your 10+2 chemistry, you must have come across different type of classifiers, is it not? Different particles of different densities can be classified by using either the very high jet pressure of air or by centrifuging them. And another good example would be the sanospheres, which I will show you when I am talking about the material characterization. These are the materials of the today, contemporary materials. So, if you check on net what are the applications of sanospheres, ultra fine fly ashes, classified fly ashes, and this is the need of the hour. Every power plant should be having the facilities to classify the soils, fly ash, and grind the fly ash, and so on, to make it as a value added material. Lot of practical work is also going on in this context. There is something known as HVAC. This is high volume fly ash concrete, which I am sure you must have come across, and this is being used for infrastructure development. So, the HVAC concept is high volumes of fly ash are used to make system more durable, alright. And these type of systems need very low water content. So, if you remember W/C ratio, the present day research is on the concept that W/C should be tending to 0. What is the meaning of this? I should be using as less water as possible to make concrete. Why? Cities like Bombay do not have fresh water, Chennai, coastal areas. Why? Most of the water is adulterated, or the sea water, salty water. Sand is not available, it is all contaminated sand. So, now people are trying to work on as minimum water as possible. So, when you balance W/C mathematically, when the moisture content decreases, C also decreases. So, it is a very interesting concept, where the water is less and the volume of cement which is required, or the weight of the cement which is required, is also less. So, you are not overdosing the concrete, and hence you are trying to create systems which are going to be more durable. These are new concepts in construction technology. What are the applications? These type of materials find lot of applications in hydrothermal and nuclear power sectors. I have been closely associated with some of these design of structures and the foundations, and this is where people are using HVAC for either piles or the foundations in aggressive soils. Check it on net, what is the meaning of word aggressive soils. So, aggressive soils are the ones which might be having a lot of sulphate content in them. So, it becomes a big challenge to lay the foundations when the soils are aggressive in nature. They could be highly contaminated soils, alright, very low pH, very high pH, different types of contamination, chloride contents could be very high, sulphate contents could be very high. So, you know the implications of these type of situations. At the same time, when you are talking about the strategic structures, alright, where the nuclear power is being produced, domes, shells of the atomic power plants, where you want extremely durable systems, and they should be thermally insulated. Is this correct or not? Because imagine inside the reactions are going on where the temperatures might go very high, and normal concrete might crack, and if normal concrete cracks, the chances are the radiations may come out into the atmosphere. So, these are very niche areas in which HVACs are being used to create highly durable systems. A lot of research is being done in the realm of materials in civil engineering. Similarly, for dams, barrages, irrigation projects, these type of materials are being used. Lean concrete is a good example. Roller compacted concrete. I don't know whether you have come across this type of thing. These type of projects have been done in India, particularly in the southern part of the country and close to Bombay, where the entire dam was constructed by roller compacting the concrete. So, sometimes when you type on net, you will get this information, and presently the situation is that people are aware of how to utilize the geomaterials for creating high value products. Another species of projects is marine projects, where it is very difficult to do underwater grouting, cementing, construction, and you have special requirements of concrete. Most of the developmental work is going on in the marine environment, pipelines of piling, different types of land creations, and so on.
Like how well understood are the properties of concrete that has large amount of fly ash, like mechanical properties?
Very well, very well. It's quite in control. Most of the construction is going on in this by using these materials. Everything, a lot of research is being conducted. The material science in civil engineering has become a big subject. It's not only limited to the way you made concrete and steel and glass and wood. Nowadays it's becoming extremely multifaceted, multidisciplinary, multi-component infrastructure materials. Different types of environmental engineering projects where you require to stop shielding against acid attacks, particularly sewer lines. Imagine the tunnels which are being constructed for carrying water or the sewage. They are mostly sulfate attacks are very high, H2S formation is there. The entire environment, because of the presence of acid forming bacteria, could be under anaerobic condition. How would you protect your structures? A big challenge. So, specialized environmental engineering projects require these type of high volume fly ash concrete, which are quite durable. Lining of the tunnels, you read a lot on the net and you will realize where these type of concretes are being used. Lining, internal lining for the tunnels in which the water is flowing or the sewage is flowing. Silica fumes is another interesting man-made geomaterial, and this is a very high end material which is used for creating concrete. Extremely fine particles, and what do? Is they clog the pores of the concrete, and hence the concrete becomes highly durable. So, silica fume is also known as microsilica, very active form of silica, super active silica, and specific gravity would be of the order of 0.5, 0.6, 0.7. So, it is a big challenge to transport this material. Most of the time this material is imported in India. So, when you are bringing it through sea liners, I think you can imagine if the specific gravities are less than water, the bulk volumes cannot be carried, because you require very high volumes for very small weights, and the stability of the ships is a big question. You should read all these things nowadays. It becomes multidisciplinary subject. So, it is a byproduct of the reduction of high purity quartz with coal in electric furnaces in the production of silicon and ferrosilicon alloys. It is a boon for concrete, but the issue is if you add more than 4 to 5%, this becomes a deterrent for gaining strength of the concrete, because silica fumes are highly corrosive. Finer the particle, surface area is going to be extremely high, and then it has a tendency to suck water, retain water. So, when you are adding it in concrete, the chances are that silica fume will absorb most of the water which is present in the concrete, and the concrete would not get water to get cured. So, that is why the dose has to be properly monitored. So, when you produce ferrochromium, ferromanganese, ferromagnesium and calcium silicon type of things, then this type of material is becoming industrial byproduct. Another interesting thing which I was discussing in the previous lecture is the reuse of tires. So, in a small area nations which are surrounded by water, particularly oceans, these type of technologies are being studied quite a lot. So, Japan is a leading country where a lot of reuse of tires is being practiced. So, if you type on net whenever you get time, you will realize that tires which are coming out of the automobile industry, which have been discarded, find a very special application for designing offshore structures, and ground improvement is also being done by using this type of elements. So, basically rubber tires are a threat to the environment, because if you stack them, they catch fire, and even if you do not stack them, this could be a place for mosquitoes to breed, and it is very unsightly. So, they collect water also, and they become the breeding space for mosquitoes. The question is, can something be done with this or not? Read the papers which are available on internet. This is where people have tried to reuse the rubber tires. I will show you one good example which was proposed by Professor Joshi from Calgary University long back, and I have the animation with me. There are several applications of the scrap tires, and some of them are road embankment. You can shred the tires, you can use them as aggregate for making the road embankments, and I am sure you will realize that once the shredded tires are being used, the elastic modulus and the bouncing property of the finished surface are going to be much better, and damage to the automobile vehicles tires would be extremely less as compared to the rigid pavements, which are very aggressive. You can think of creating subgrades which are thermally insulated. Imagine the countries where the temperatures are extremely low or very high, and you would require a thermal insulation layer between the formation and the embankment or the crust of the pavement. So, this is where very judiciously these type of materials have been inserted, and a lot of case studies are available in the literature. You can lay your hands on and become state of the art. Another good example is asphalt rubber pavement. So, you can mix the asphalt and the crumb rubber, and you can create pavements. Most of the developed countries have used this technology, and hence this type of finished product gives you more riding quality and comfort. CRB you must have heard about, no? Crumb rubber bitumen. So, this is another form of utilizing the scrap tires. You can shred it and you can mix it with the asphalt, and you can create pavements out of it. What are the pavement requirements which are fulfilled by this concept? So, you will realize that durability increases when you enhance the flexibility or rigidity of the system, and this can be controlled by adding the shredded tires. Deformation modulus can be controlled. This is what you are talking about. One of the examples is people have shown that the deformation and the modulus of deformation can be changed by using this type of composites. Thermal resistance is the key word. So, these tires act as the thermal insulators. In our country also, sometimes we should be proposing these type of test tracks, and we should be testing them where the climatic conditions are very harsh. Northern part of the country where sub-zero temperatures are there, and because of what happens, freeze and thaw, the pavement gets distorted. So, there this seems to be a good technology. When you add shredded tires with the asphalt, you can enhance the rutting resistance also. You must have studied about the rutting of the pavements. So, because of more bouncing effect, when you add the rubber tires chips into the asphalt, the rutting resistance can be overcome, can be enhanced. Wearing can be reduced, wearing of the tires. Shrinkage resistance can be reduced, and so on. So, there are a lot of applications you can think about. We can modify the skid resistance of the pavements also. The biggest problem in the temperate climates is that due to very high temperatures, what happens? The asphalt or the bitumen melts, and particularly countries like India, and because of the melting of asphalt and bitumen, what happens? The skid resistance decreases. So, this causes a lot of accidents on the roads. Now, I will show you one animation where you can appreciate that how rubber tires with steel mesh can be utilized for creating different type of turfs or embankments, particularly for the sports velodromes, where the vehicles are tested. It could be a cycle velodrome, it could be a automobile testing facility where you are creating a velodrome. So, this is how it looks like. These slides I have borrowed from Professor R.C. Joshi, University of Calgary. This is his idea, but I thought of sharing with all of you. So, what's done normally is that you take the rubber tires, you splice them, and after splicing you flatten them. And once you have flattened, this becomes one of the units which can be used for creating. So, if you talk about the width of the pavement and the longitudinal direction of the pavement, you can stack these units one by one, and you can rivet them by using anchors. The next layer would come of the another layer of anchors, followed by another layer of the spliced rubber tires, and keep on repeating this as long as you achieve the desired height of the system. So, I am sure you must be realizing that this is a good clever idea of utilizing the industrial byproducts. Automobile industry would be very happy if you can encourage the practice of this type of construction, because you are saving so many millions of tons of the natural resources for creating embankments. This type of technology should be promoted and they should be practiced. Yes, please.
Are they used in only flexible payments or both in rigid also?
You have to do a mixed design. If you remember in your transportation engineering course, so you were designing asphalt for your requirement, is it not? So, you can use a rubber tire chips as a additive and you can design the whole mixture.
Can they be used in rigid payments?
And normally in rigid pavement you will not use, but yes, if you want to modulate, if you want to make a composite system where the bottom portion of the pavement is rigid and top you want to give cushioning effect, particularly the places close to the signals where most of the braking action takes place, where you apply brakes, where the rutting is maximum. So, there this seems to be a good idea. You can create a composite system in the embankment itself or on the track.
It increases the shrinkage resistance.
Yes.
But can the problem of swelling up as well because bouncing effect?
Yeah, so imagine the density of this material is going to be very much because they are thick sheets. So, one of the ways to negotiate with the swelling pressure of the soils would be, what is that you do normally? CNC, compacted natural clays. So, on the swelling soils you are nullifying this effect of swelling pressure by giving a gamma into H. So, I can save this gamma into H layer, and what can I do? I can put this material, I can counterweight, I can apply the counterweight and I can get rid of the swelling of the clays. CNC material, compacted natural clays are normally used to balance the swelling pressure of soils in field. So, imagine if swelling pressure is 2 kg per centimeter square, you require a very thick layer of compacted clay, which is clay itself is not available in the market nowadays, clear. So, these are the situations which are forcing people to think ahead and apply new concepts. It's fine. Yes, please.
So, which all properties of soil get improved when rubber tire chips used for soil stabilization?
See, people you will find in literature, actually I have not done much research in this area. So, I am just talking about from whatever I have learned from the literature. Basically what they do is they modulate the swelling properties, and mostly very fine shredding of these tires could be fiber reinforced soils, because if you remember that the composition of the rubber tires would be carbon, and carbon could be used as a fiber also, or if you can grind it and cut it and chop it in very small particles, then it could be used as a amendment of the soil properties also. You can mix it with the soils. Now, these are the ideas which you can use and you can create your own recipe. And then what you have to do after creating a recipe, you have to test it in the laboratory and prove how the properties have been modified and then recommend them for applications. Fine. Now, these things are going to be useful now in days to come, and using these concepts we are trying to help the industry. I would like to melt it, I would like to amalgamate this with something else, I would like to create a. So, all these things our Mr. Goli is working on, a lot of new ideas and demonstration of technology. Yes.
Sir, when on freezing, the rubber has a tendency to become solid, right?
That's right.
So
So, rubber may also may crumble at low
so
temperature. Yeah, so what you are doing is very judiciously, you are just trying to create a barrier, thermal barrier between the formation and the crux, what do you call it, not crux, sorry, crust of the embankment of the pavement. So, there you just putting as an insulator. So, this system itself will be insulated from the environmental conditions. Now, this is an interesting way of creating systems, all right.